This question is about gas volumes. TNT is an explosive because it can decompose very quickly and exothermically to form a large volume of gas. An equation for this decomposition is shown. Calculate the volume of gas in meters cubed measured at 1250 degrees C and 101,000 pascals produced by the decomposition of 1 kilogram of TNT, and it's given us the MR and the gas constant. So we can tell we're probably doing a PV equals nRT question here, but I think the first thing we would need to do is work out how many moles of TNT we actually decompose. So that remembering that moles is mass in grams, so a kilogram is 1,000 grams divided by MR. So if we do that on our calculator, we'll get the answer 4.4053 moles. I mean, you can round that up a little bit further if you like. Now the question is about gas. It wants to calculate the volume of gas, and we can see that there are a lot of gases here. So the number of TNTs to the number of moles of gas is 2. 3, add 5, add 12, so that's 20, or 1 to 10. So the number of moles of gas equals 10 times 4.4053. So it's keeping that on our calculator and just timesing by 10. 44.053 moles. And then if we look at the other numbers, we can see that our pressure is already in pascals, so that's okay. Our temperature though needs converting, so we're going to add 273 to get the temperature in Kelvin. So 1523 Kelvin. And then we can rearrange PV equals nRT to say V equals nRT over P. So we're going to take our 44.053, times it by the gas constant, times it by our temperature, which we just worked out, and divide by our pressure. And this will give us volume in meters cubed, because PV equals nRT gives volume in meters cubed, because the gas constant R is in joules per Kelvin per mole, and that relates to meters. So type all that in our calculator, and we get 5.52 meters cubed. And then we just go back. It doesn't ask for a specific number of significant figures, so I'm just going to keep it at 3. 5.52 meters cubed. The next part of the question says alkenes have the general formula CnH2n. When alkenes undergo complete combustion, 1 mole of alkene reacts with 3n over 2 moles of oxygen. Calculate the volume of oxygen needed to completely combust 200 centimeters cubed of but1ene. Okay, so we need to have a think about what but1ene is. But1ene is C4H8, so N equals 4. Okay, so if 1 mole makes 3n over 2 moles, so 1 mole reacts with 3n, so 3 times 4 over 2, so 6 moles. Now, volumes of gases, moles are proportional to the volume, so 200 centimeters cubed reacts with 6 times 200, because 1 reacts with 6, so 6 times 200, which would be 1200 centimeters cubed. Alkanes have the general formula CnH2n plus 2, and they have given us an equation for their complete combustion. It says determine X in terms of N. So if we look, X is the number of oxygen, molecules of oxygen, but we can add up the number of oxygens here. So we've got 2N in the CO2, and then N plus 1 in the H2O, so that makes 3N plus 1. And because there's a 2 in the formula of O2, then once I know that this is the number of O's, so X equals 3n plus 1 divided by 2, because it's O2. So that would be our answer, 3n plus 1 divided by 2.